Okay, let's start the manufacturing processes with basically just an introduction, overview of manufacturing. This introduction, this first unit, there's actually four parts to this PowerPoint. I'm going to divide it up. This first unit, we're just going to focus on what is manufacturing and introduce some different concepts. Let's start off with a basic definition. What is manufacturing? It's the act of making something or a product from raw materials. And by raw materials, that varies from one factory to another. For instance, if I'm making appliances, raw material might be sheet metal, right? If I'm making steel, sheet metal is the final product, but the raw material might be iron ore, scrap metal. So it varies. So whatever goes in is considered raw materials. What comes out is the finished product. Yeah, manufacturing is important. Could you imagine without having manufacturing what it'd be like? Technologically, we wouldn't have computers, TVs, cars, air conditioning, anything like that. And economically, I've got a video about how to make a pencil, how they make pencils. And then in the discussion, go and talk about how much it would cost if we didn't have that technology or didn't have the manufacturing. And historically, before manufacturing, people just basically did farming. That was a big thing just to survive. Lived in hunting and gathering groups, very basic agriculture, using stone tools. Yeah, manufacturing is important. Our life is the way it is just because of manufacturing. It'd be so much different. So this is a definition of technology. It's the application of science to provide society and its members with those things that are needed or desired. Um, this is what engineers do, is they create technology using science, from science. Somebody once, in fact, I'm going to tell a little story. Somebody once said Bill Nye, the science guy, really isn't a scientist. He's an engineer. So he really doesn't know what he's talking about. Being an engineer myself, yeah, it kind of rubbed me. But if you're going to apply science to create technology, you got to understand the science, right? So take what it is. What the guy basically said is he doesn't understand what science and engineering is. Provides the products that help a society and its members live better. Yeah, we talked about that in the previous slide. You are living better, right? And what do they all have in common? They're just manufactured, right? And it makes technology possible. And again, go back and watch that pencil example. We wouldn't have pencils if we had to make each one by hand. And it's about money, right? So manufacturing is about 20% of GDP. Um, it's not that much you think about, right? You know, there's some bigger numbers out there. So we'll get to service, but think about the other things: agriculture, mining, things like that. Without manufacturing, making the tractors and the farm equipment, we wouldn't have that. Only about 1.3% of Americans live on farms now. That's down from about 90%, a couple hundred years ago. Construction again. Look at the manufacturing makes construction possible, the buildings and things like that. And even the service sector. If you go to McDonald's, watch how they fry hamburgers. Look at the technology in restaurants. Think the technology in your phone company, your internet provider. All that relies on manufacturing. So this is the foundation, right? That everything builds off from. Even though it's only 20% of our GNP, it's a big chunk of what makes things possible. So what is manufacturing? Well, it's an old Latin word, manus, hand, factus, make by hand. Uh, Modern manufacturing, if you see a lot of manus there, there's something going wrong. It's all mechanized and automated pretty much, and that's the goal of it. In fact, most highest paid job in a factory are the maintenance guys. They keep the machines that make the products going. Uh, Again, I'm going to use the Kia example. 1,500 people work for Kia corporate in America, but all the cars are made here in the United States. If you see it on the road, it's made in Alabama. That's not that many people really, but the automated factories and things make it possible. So what is manufacturing technologically? Well, it's an application of physical and chemical process to alter geometry, properties, and/or appearance to make parts or products, and it includes assembly. I'm going to use this. Just take a few moments to talk about assembly. If you've ever been to IKEA, what you'll notice is that people have to assemble their furniture. Well, it's an interesting study. They found that if people do the assembly themselves, then ask afterwards, how much is that bookshelf worth? Oh, they'll say, oh, it's $100 because I put so much work into it. If they have the exact same bookshelf and somebody else assembled for it, they say, well, how much is that one worth? $70. As you assemble something, and this works in factories too, you add value and you think of how much value you're adding, but there's a perception variance. And you're going to find that people don't appreciate your work if you're in assembly or at a machine shop as much as you do. And just that's just the way it is, right? They did the same thing with cake mixes. In the 1950s, they came out cake mixes. And they included powdered eggs. All you had to do is add water, beat it up, and put it in the oven, right? A disaster. A disaster. So what they tried is they said, okay, we're going to take out the powdered eggs and see what happens. And they had to add eggs. Well, it turns out adding 3 eggs to a cake mix was just right to make the people think, okay, I made a cake. I just didn't mix something up and throw it in the oven. I actually made a cake. Assembly, like I said, that's a big part of it. Making something, yeah, it gives you a sense of pride and increases the value. And sequence of operations, that's a big thing that Henry Ford did, is he put things in proper order, and that's the whole thing, right? And we're going to focus on improving that sequence and adding value. And this is just a quick figure. You start off with the raw material, it goes into a big building or whatever, and you start machining it, tooling it, power and labor, assembling it, whatever you have to do. And then out comes a part that you're going to sell. And of course, you got some scrap and waste. And we're going to focus on that too a bit here. Okay, economically, it adds value. And I want you to think of that term value. What does that mean, right? What does that mean? And who determines what value is? And think about that. We'll discuss it in later units. When you change the shape or properties by combining it with other materials, right? So it's assembly or processing, something like that. And again, this is the figure you start off with. It's got some kind of value. You add value in your factory, hopefully, and the end product, the customer pays you for it. It's got to add value. And again, think about what value is and who determines what value is. So industry here, we're talking about enterprises and organizations that produce or supply goods and services, right? So that's why you can get away calling it the restaurant industry or the airline industry, telecom industry. So we're shifting away from making products strictly to controlling processes, and that's what industry is, controlling the processes, and manufacturing also. 3 types. Primary industries. These are ones that farm, mine, lumber, timber, that type of thing. They exploit natural resources. And you got the secondary. They take whatever comes out of the farms to the mines and stuff and converts them into consumer and capital goods. Manufacturing is the activity. So you got construction, making appliances, generating electricity. And finally, you got the third industry, tertiary industry, service sector. And these are the things that control the money and provide the resources. By resource, I mean money to make things happen. And these are the service industries, right? If we didn't have restaurants, we wouldn't be able to travel and things like that. So there are 3 types. Just remember that. Okay, we're just going to focus on the production of hardware. This is stuff, right? So nuts and bolts, forging cars, airplanes, computers, plastic, ceramic. If you're looking for a job in the travel industry, this is probably not the class you want to be in. This is production quantity. That's designated by the letter Q in economics. And I'll do a film on or a quick video on how price and quantity are related. Basic economics. is how people, facilities, and procedures are organized that determines the quantity, right? And how much you're going to sell, right? And there are three ranges. I don't know where they come up with this one, but low production, less than 100 units. Medium production, more than 100 but less than 10,000. And high production, 10,000 or more. And we're going to talk about product variety, P. Later on, I'm going to talk about P meaning price, but for this chapter, P means product variety. Different product types and models, right? In this, well, let's talk about this slide first. Different products have different features, and they're all different. Think of cars, right? I want to think about cars because I'm going to talk about that a bit. Some have more parts than others, yeah. When the number of product types made in factory is high, it indicates high product variety. And this is, I'm going to talk about cars. This is what got GM in trouble. They had different models. They had Buicks. They had Chevys. They had GM brand. I mean, they had more brands than Pontiac. Different product types means you have to manage a lot of variety. And here's an interesting thing. People think they want choices and variety, but not necessarily. They did a study at a grocery store. They had out jam, right? You know, you sample jam, you're supposed to buy one. So they had 12 jars of jams. You could sample and buy one or whatever. Well, after sampling, only 3% bought jam when they had 12 out there, right? Well, then they tried the same experiment. They had 3 types of jellies, and sales went up to 12%. Turns out that the more choices we have, our brain starts twitching. And I won't talk about the pickle choices here, but our brain starts twitching. People think they want choice, but they don't. They want the illusion of choice. And Japan actually does a good job of this. If you go buy a Toyota, there's not a whole lot of choices out there, right? But yes, that's the biggest car manufacturer in the world. Well, it might be number 2. Volkswagen's pretty big too. Again, not many choices. So I told that story about the jams and the cars. People want the illusion of choice and selection. So yeah, if you get out there and you actually start working on processes and products that you're going to make, try to do that. Give them the illusion of variety without giving them much variety. Actually, it's an interesting study. It works out that you'll sell more that way. So let's look at this chart here. If you have high product variety, your production quantity of that product isn't going to be very much. Low product variety, higher production. Okay, so if you're making tomato soup, that's all you're making, you're going to pump out a bunch of cans of tomato soup. If you're making about 40 different types of soup, you're probably not going to make a whole lot of each type of soup. And that's what they mean here. A little bit more about variety. If you got soft product variety, right, there's small differences in the products. If you look at a Toyota assembly lines, their cars, there's not that much difference between them actually. And every assembly line can make any type of Toyota car except for one, and that's their Tundra. And that's a hard product variety. A Tundra is a lot different than a Corolla. So it's a substantial difference. And that's what they mean here. Soft product. Okay, yeah, you can change things, tweak things. Hard product is so different, you got to have a whole different process. So what is manufacturing capability, right? Well, that's where you got the process and the systems, to include people in those systems. Transform limited range of material into products of increased value. It sounds easier than it is sometimes. Think of Tesla here. They're having some issues because they can't get their processes right. The prototype cars work fine, but they go to mass produce them, they got some issues, right? So there are 3 building blocks: the materials you use, processes, and the systems. These are all in the modern manufacturing, and we're going to focus on that quite a bit in this course. So capability, there are 3 parts to this, right? Technologically processing capable. Is it even possible to make this thing, right? or do you have the processes, or even is it technically possible to even make this thing? And I've seen some pretty dumb designs coming out of engineering that there's no way we could make that. And I won't use any examples, but you'll see it too when you get out there. Physical property limitations. What can we do with this product, right? And again, I've seen products that you just couldn't make, right? And I've seen it right here in Mississippi County, right? In production capacity, how much of this can we make? How fast can we spit it out? You'll be surprised how many people in scheduling will put in a big demand for a product, and you just don't have the capacity to make it. And it happens all the time. So what's technological processing capabilities? It's a set of manufacturing processes in the plant or company. This includes skills, right? Also, they're certain for certain materials. Processes are designed for certain materials, right? So when we needed ventilators, you can't just automatically turn a car factory into a ventilator factory. This is from the pandemic. It just wasn't suited for that, right? The materials are different, everything like that. They eventually converted, but yeah, it took a while, right? And not only the physical processes, again, it's the skills in there. If you're going to design a very technical product, you got to have the skill. Atari is an old, these have owned the electronic game industry. So they were making it. All of a sudden, there's this big demand for Atari systems. So they go down to the local employment office and say, hey, we need some people to build us some basically small computers. So they send these people down. And the exact quote is from Atari, I didn't know such people existed. They weren't capable of building anything. You got to have the skills, right? You got to have the skills. That's how important it is. The right skills for the right job. And limitations, the physical, you just don't have the space for it, right? Or the material, machines, whatever it is. And just think about it. Let's say we want to build 747s or big old jet airplanes in Blytheville. We really don't have the factories that could do it. We don't have the equipment. We don't have the ability to move those planes around. You just got to have, there are some limitations about what we can make, what we can't make. So what is production capacity or plant capacity? This is how much you can spit out of a plant, the maximum quantity over a given time period, right? With certain conditions. Again, operating conditions refer to the number of shifts, hours, manning levels. Capacity is also in terms of output limits, tons of steel, number of cars produced by it. And let's go back up to operating conditioning. The production of equipment. How fast can a piece of machine spit out what we need? And again, we're going to focus on improving this, making it bigger or faster, improving capacity. And that's what I want to focus on in this class, improving manufacturing processes.